Tonight on Catalyst.
I've noticed with Ross, his mind thinks in a different way.
And what makes a genius, nature or nurture?
There are massive amounts of activation and metabolic activity that characterize these gifted brains.
Science shedding new light on the brains of gifted children. A question on a lot of people's minds. Just what does it take to make a genius? Is it your parents, your upbringing, or just plain luck? Well, that's what one scientist is trying to find out by studying the brains of some very gifted children.
Ross Newman is a gifted child. Even his parents are baffled about his exceptional intelligence.
Early on, when he could read, I bought him an encyclopedia that's about 700 or 800 pages, and I gave it to him for a birthday present, and he just sat down and read it.
Every parent wonders why some kids are more gifted than others, and that's the question neuroscientist Michael O'Boyle is trying to answer. For the first time ever, he's comparing the working brains of maths gifted children with average children to try and find out just what makes a child exceptional.
I think there's an intrinsic interest that everybody has with regard to what the brain of a budding math genius or an Einstein might look like. And so basically what I was really pondering was, how is it that these young children, 10 to 15 years of age, have been able to learn or acquire such high-level mathematics?
Ross Newman is one of the kids Michael O'Boyle is studying because Ross has an exceptional grasp of maths and physics. What sort of marks do you get in science exams at school?
Normally the 99th or 100th percentile of the science tests that they give us.
So, top of the class?
I guess you could say that.
Mm-hmm. But he's not heading to school today. He's actually heading into the physics department of the University of Melbourne, where he spends every Friday with Roger Rasool and his PhD students, helping them carry out their research.
I think Ross is a very powerful thinker and a very special young boy. Who knows in a few years' time? I think he'll be one of our great thinkers.
But what makes Ross such a great thinker? It doesn't seem to be inherited from his parents.
I don't know where he gets his interest in maths and his expertise in maths or interest in science from. I have no idea.
No, always say, I can barely add up, and Jeff always gets the noughts in the wrong places.
Every parent would like to know how to make their child into another Einstein. A couple of years ago, when researchers looked at Einstein's preserved brain, they found unusually well-developed parietal regions on both sides, and also a higher number of transmission cells known as glia cells.
So I began to think that maybe if a quintessential mathematician like Einstein had these certain aspects of brain characteristic that were special, perhaps these kids who seemingly in the absence of any kind of formal training are mathematicians of note already, had something about their brain that was different as well. Hi Ross, how are you going?
So Michael recruited a group of kids with an exceptional ability in maths, including Ross, to look at how their brains compared to average kids. They were given a task where they had to rotate shapes in their mind.
I'm going to be presenting you a set of stimuli, and what I'd like you to be able to do is look at those four and tell me which one of those matched that target item just rotated in space. So there are sort of 4 test items and a target, and you'll press a button to indicate which one of those actually match. So that one matches that one.
Yeah, I did that one.
He put them in an MRI so he could see their brains performing while doing the geometric task. As the various images flash up, Ross has to look at them and pick which one would fit the target shape using buttons on the MRI.
We impose image generation and mental rotation into the mix, and you should see some very dramatic changes.
And the changes are dramatic. As Ross applies himself to each problem, you can actually see different areas of his brain light up. As he reaches the resting visual task, the colour and activity fades away. When Michael analysed his results, he found that the gifted kids were different. Their brains were far more active on both sides compared to the control group.
There are massive amounts of activation and metabolic activity that characterize these gifted brains. In fact, the amount of activation in regions like the parietal lobe, which are these tail end regions here, is about 6 or 7 times greater than it is in those of the average ability. What really separates the gifted, however, from the control subjects is all of this anterior activation.
This front end of the brain directs attention. It's a measure of your ability to focus on a task.
The gifted are activating those regions very, very extensively, where those in the control condition are not.
So the gifted kids can connect more areas of their brain to create highly efficient and focused attention. So do the people around Ross notice anything different?
I've noticed with Ross, his mind thinks in a different way. You can pose a problem to Ross, and Ross can actually say, no, let me think about that. And you get a feeling for that mind is actually ticking in a different way to most students.
Do you not notice like you tend to concentrate on a problem more than other people when you've got a problem to solve?
Oh no, it's just my area of interest, so it's very easy to concentrate on problems that you like and that you find easier to solve.
So you don't feel unusual or any different from any other kid? But these preliminary results do indicate that Ross has something in common with Einstein.
So glia plus parietal resulted in someone who was particularly good at mathematics, which of course is an interesting lead for what happens with regard to the students and the children I've studied, because that's essentially what you find in them as well.
So has Michael cracked the mystery of the maths genius?
By studying individuals who are exceptional in mathematics and looking at their brains, we learn a lot about the different kinds of contributions that these different areas make, and may in fact somewhere down the line be able to develop intervention techniques or learning environments that capitalize on the way all types of brains actually learn.
So at the moment you can't give any hot tips on how to become a maths genius overnight?
No, I think you're sort of born, not made.